Hello everyone, I'm Clashy from Hoax Games, and in this video tutorial I'm going to explain to you the most important settings of iStep and how to use them correctly. So let's get started. The first one is the animator ICAP has layer index. This has to be set to the same layer index that if you go into your animator controller, it's actually the layer index where you have your ICAP has enabled. Here it's always your ICAP has where you can enable it. And you always have to use one layer where the iCapes is enabled. And I usually use the base layer for that, which is index 0. And that's also what we have set up here, index 0. This is important for the animator loop to work. Otherwise, the foot IK script would be like disabled. So this has to be set up correctly. The next collision layer mask, which is set to default, UI and enemy, in here. This is the collision layer mask that iStep reacts with. So here the level is all set to default, so it collides with that. The next thing, trigger collision interaction, which is set to ignore. You can also collide with triggers. So if I set this to collide, let's show you, we can create a game object. Let's create a cube. Let's put it here. Let's say trigger is enabled. Let's see if we collide with it. Yes, we do. And to show you that that only iStep is colliding with it, you see it here that the collider itself is not. You see it on the bounding box of the sphere. Of the capsule collider. iStep is still reacting this trigger. So this is if you want that effect. You can use it. It's not something that it's commonly used, but it's in here, so you can set it up if you want to. Then next, let's change this back to, no, let's let it. So next, reset to default value reset speed. So this one is the multiplication speed that is applied to when you move from a state where you have iStep on to a state where iStep is basically off. And to have a smooth transition, not like let's show you, not the transition like that. This looks very bad. You don't want this to be this way. You want this to be in a smooth way, like that. If you want this transitions setup, if you want to set up the speed of this transition, you have to use the reset to default value speed. So if I increase this to 10, for example, then this would react very fast, like you're seeing it's fast. If I put this to, let's say, 0.1, it should be very slow. So yeah, this is really slow, so that's too slow. So let's set it back to 1. This works pretty well. And yeah, that's this value. The next one, activate crouch specific behavior. This is if you have some animations or if you have a character controller that can crouch and it has crouch specific animations, you can set this up with either by code by activating this variable. You see, if I activate it now, it's not working. It's just basically disabling iStep because this is the wrong behavior for this state. But you can do this either in code by yourself, or you can use this here. You can put your animation name in here, and if you do that, you can put your animation name in the force activate crouching behavior list. If you do that, then this crouching specific behavior will be automatically enabled. So I'm doing this manually now because I'm going to fake how this effect works with using the body position offset. So I'm going to fake some crouching here and show you how this effect behaves. You see, if I crouch here like that, if I have an animation that looks similar to this, and I would go up in here, he raises the body position. So this is the difference to the normal behavior. In the normal behavior, you actually want to move your body position down, and in this behavior, you want to move it basically up. And we have also a tolerance for this effect. So the tolerance is the next value that you can set up, crouch correction tolerance. So I can still make him move down if I want to. with a specific percentage. So this is 100%. So this would be like effect being disabled, and 0 is like the effect is always moving up. But I can make, I don't know, let's say 0.1, so I can move up, but I still have some tolerance to move down if I want to. So if I move up like that, it's still working, even though the character is crouched. So that's this, what you can use for crouching. This is, like I said, just a fake that I showed you, because, I mean, you can use the body position offset to create some cool effects if you want to. But yeah, if you have a good crouching animation, then use this, please, and not that, and set this at 0. Yeah, because yeah, it's just a better way to have better animations. But anyway, let's move next. Like with this list where you can trigger the crouching, let's disable the crouching. Let's put this to 0. We are back to the default settings. So if, like you can do with the crouching, you can also invalidate iStep with some specific animations. So in here, like jump start and some other animations, I can basically have a smooth transition, like I showed you before, to iStep being enabled and disabled, like the same way with when I set the check rounded distance to 0. This also, if I'm in one of these states, it also disables basically iStep. It reverts it back to its default values, and it also uses this reset to default value speed. So next is the global character Y offset. For the character global Y offset, we have to use a different character to show you, or I have to use a different character to show you, because this character is set up correctly, or let's say it fits with the animations, but I have a character in here that doesn't, which is this one. So let's go into scene. Let's this aside. This character here looks like everything is correct at first sight, but actually if I disable the foot IK script, see that it's not. So we have an offset in here, which is caused probably by the feet length not matching with the given animation. You can set this up in the animation directly and fix it. This would be one way. So if I take this idle animation here, it's actually the idle that is playing. I could also just go in here and set up an offset of minus 10, for example. So it moves the feet up. But I don't recommend doing that, because you may want to use this animation on multiple characters, where at one character you need the offset and in another you don't. Then you would need to duplicate these animations and so on, which is, yeah, it's not a perfect way of doing it. That's why iStep has this character, global character Y offset. So we can use that for this. It's set up to 0.11. If it's 0, that's nice. If it's 0, it still matches, and you would ask why. But look at the knees. If it's 0, the knees are just bended, and this is not what you want. So why does this happen? Obviously, this happens because the IK foot height is at 0.24. So I will show you how this effect, how the global character Y offset has to be used, and how it has to be used in combination with the IK foot height if it's set up wrong on your character. But first, before I do that, we have to set the minimum movement threshold to 0, because if we don't, so let's say this is this value, and I change the foot height, doesn't change anything, and this is because it's culled, and it's culled because the IK that in the animation hasn't moved, and if it doesn't move enough, this value culls them. So if I put this to 0, it's updated in every frame, so it stops culling them, and we see the effect. So if you have a character like that and you want to set it up correctly, you should put the foot height to 0. Also, remember, you should always, if you are trying to set up some settings, always move minimum movement threshold to 0. so that you see your changes. That's very important to know. So this is what we did right now. We moved this foot height to 0, or basically 0. It can never be 0. It's minimum 0, 0, 1. If I set the character offset now to 0.11, and I'm happy with how it looks or how it's placed. Next, I would set up the foot height. So set up the foot height correctly. We are just going to take that and put it here. Our character is not colliding with this trigger, but we are going to make it collide with it. And you see it's inside because it's our foot height, which is basically 0. So we have to increase this until it matches in here. I think it was 0.24. This was the value I had, which looks pretty good. So let's set this up like that, and everything should work. So that's this. Let's go to the next setting. So actually, this is how you should start. First, you should check out if your character needs this global offset. Then you should try to set up the foot height correctly. These are the two first things I recommend doing for every setup of every character in the beginning. So the next is IK placement weight. So let's go to the game. I'm just using that. The placement weight is straightforward, just how much weight is applied to the IK foot placement solution. This setting, I mean, you usually have it always to 1. You don't want this to be something else. Usually it's still here if you want to make some changes, if you have some special cases. The stiffness, it's how fast the transition applies from this to that. Basically, it has the same for rotation, for upwards extrapolation, downwards extrapolation. This is all optimization. So everything that is optimization, we are not going to cover in this video. So let's move down to also automatic foot rotation based height adaptation. This is also optimization. So the next most important settings, or actually the most important settings for setting up the behavior of iStep, is IK max correction, body position max correction, and check grounded distance. These are actually the most important settings for setting up the behavior of iStep. After, of course, you have set up your global character Y offsets, if you have any. Usually, I hope you don't. And setting up the correct foot height. These are the steps you do before you set up your max corrections. And the max corrections are basically the most important thing for how everything behaves for iStep, how they react to the world and everything. So yeah, like I said previously, a lot of these settings here in the IK placement are optimization that are not covered in this video. Foot length, foot width, you have to set up correctly for your character. That's very obvious. Also the foot forward bias. Yeah, these values have to be right, but you can set this up yourself. I mean, that's very straightforward. The anti-downward intersection stiffness, also optimization, not covered here. Max rod angle at which the ground is detected as ground. So you can clamp here when you are grounded or not with this kind of states. And also when the feet should adapt to ground angles, you can clamp everything in here. Minimum movement threshold, like I explained before. So this would be like 5 millimeters right now. This depends a lot on your animation. If your idle animation idles around a lot and has a lot of movement, you have to think about raising this. And if idle animation is completely static, then you can even set it to 0, but I don't recommend that. So have some value in here. But yeah, for now we have 0 because, like I said, set up the settings. The next is glued to ground normalized threshold. This also optimization is glued to ground distance threshold, also optimization. Only adapt rotation when glued to ground, also optimization. But these 3 values here, this is how your foot would start adapting to the ground for rotation. It's all rotation based. So let's move next to the body placement. Here we have, let's go and show it. Here we have the same as before with, it doesn't, it's, that's now an interesting case. What I wanted to show you, because the body position isn't changing here, because we have here a trigger. So the body position is still on the ground, so everything is fine. But if I change this from trigger, normal collider, now the collider is pushing my object up. So iStep has to correct this placement. And for that, this is used. So it's moving the character basically down. It's like before with the IK weight, it's the body placement weight. The next, stiffness, again, this is optimization, body position max correction. This is one of the most important settings. So what you set up here, your character will adapt to. So if this is set to 0, it's not going to adapt at all. 0.1, 0.2, with 0.2 it's enough for this case now. But I have 0.7 because I want to be able to adapt to 70 centimeters in here. And for the IK max correction, we have 55. So if this is 0.1, it's adapting. But this is because it's not the trigger and the body position is way up. Because you see, the body position is on top of this platform. But if this would not be the case, like for example, this is a trigger again. See, the feet is on the bottom. I'm using this trigger because it's easier to show you all these things with the trigger. In reality, you would have some geometry where in one case it reacts and in another, in one case the feet is above the 0 position, one it's below. This all depends. If I move around, the feet can be on top of my 0 position, and then the IK max correction would adapt. But in this case, I'm going to show you here, because in here with the, I'm going to show it by this trigger, because with that, it's really the height that you set up here is what's going to end up the correction. So that's how this works. Anyway, let's move to the next thing that we have here in our parameters. Body position max correction tolerance. The tolerance is an optimization. It's used for special cases where, let's say, need a snipping to show you that. Yes. I think I have to draw something now. So I will try draw something in here. So in case you are moving, say you have here platform like that, all right, and your character is on top of the platform, and the body position max correction is exactly this height. It's exactly this height. Then the feet would try, or would stutter in between trying to adapt to this position here and trying to not adapt at all, because it's the edge case where this, for example, are 70 centimeters, right? This is 70 centimeters, like my max correction, it would stutter, like moving down, not moving down, so moving up, resetting it, because we cannot move more down than this value, we cannot correct more than this value, therefore it disables the effect, and it starts moving up and down and up and down, and this is not good. And to avoid that, we are using this tolerance value, which if you are on the top, so if you are here like drawn, if you stand here and you didn't, so if you were on the top from the beginning and you didn't move down yet, it's going to not place the foot downwards, it's going to be upwards. And if you were here and you are moving, let's say like this upwards, okay, it would start correcting the position, And when you are again on the top, that for a specific time it doesn't starts to not position it once, so the correction gets 0. If the correction gets 0, this value, this tolerance, it's in percentage, it's subtracted from this value, and then you would not adapt your food anymore. And this is just to solve this issue with the stuttering. That's why this is used for. So next, increase body position max correction with forward foot distance. This value, for example, I'm going to show you that. Also in here, I'm going to try to draw it here. Let's say if you have some steps and your character has its feet, this is your character, like that, all right, then depending on this distance here, that the feet are apart, it's going to automatically increase your maximum body position correction. So this one, this 0.7, this is 1, it would get increased in relation to this distance here. All right, if it's 0, it's always going to be 0.7. So why would you want stuff like that? You would want this, for example, for cases like this very steep stairs. You would have this issue in here that you would want that because you want here the body position to adapt more in this case when you move and your feet are more apart. And for example, if you are standing like this and you have one foot in here and the other in here. Sorry, okay, forget that. That's a very bad drawn. I will explain it in a different way. Let's take a step again. For example, if your character is standing in here, okay, so this is this step here, and this one, it's like this one here, and this one here from the height perspective. If this foot would be here, the second one, it would create something like that, and this can be problematic. So you want this to not be too much of, I mean, you don't want your feet to be like this. You know what I mean? What I try to say? This is your character. This is your second feet. You don't want this to be too exaggerated, and that's why you set this up, this value, sorry, not this value, the body position max correction, you set it up for static poses to look right. So you set it up for the knee to look something like this. All right, you know what I mean? I think you get what I want. I try to say here. But in this case, if your feet are more apart, you want this to be able to move to up to here. Okay? All right, I think you get the idea. Otherwise, just play around with the values a little bit, and then you will see what looks best for you. Then next, can body position move higher than grounded position? Actually, show that with this trigger, because with that it's very easy to show. So actually I'm moving up in here. You see, I'm moving up in here like if it would be a collider, even though it's not. It's just iStep colliding with this. And if I disable that, you see the height stays the same. If you want this to behave like that, please disable that. Otherwise, enable it. Then it reacts to triggers like with normal colliders. So that's that. Body position offset it's for running the character. But please don't use the body position offset to correct the global character Y offset. Please don't do that, because the body position offset only changes the body position and not the feet, and it would not give the best results. So use that for this Y offset that I told you previously, and use this for only changing body position to change some poses. If you just want to real time, you can do that. So the check grounded distance should be always at least as high as the body position max correction, because if you are not grounded, if this returns false, then iStep tries to revert its settings to like if it disabled. This can also be higher, for example 0.8, but usually it's going to be 99% of the cases almost the same as that. It can be a little bit higher sometimes if you want to have different transitions somehow, like you don't want this preset to default value speed being applied immediately, have the default transitions inside of iStep's update loop, then you can have this a little bit higher. You have some tolerance where other algorithms are used for the transitions. Basically, actually having here some tolerance can always be a good idea, so you can have that. I didn't have it here, but you can do if you want to. You just have to try and find the best values for you. Here we have 0.55 for the radius. Set the radius, let's check, like in here. But if we go back, let's go away from this character. Let's go back to the monster character. On the monster character, I have set up 0.6 for the radius, and in here the radius is 0.5. Now you would ask, why is that? Check your scale. If you want this to match, then so if you want it to match with your character controller, then you should check the scale in this case, because the character controller doesn't show you that. So if you apply 1.2 with 0.5, it's exactly the 0.6. Yeah, it scales because, I mean, if you scale that, this is also scaled, but the value that is shown is the unscaled value. That's how the character controller here works. If you have a different character controller that behaves differently, you have to check what radius you need or works best for you here. The auto unground upwards velocity, this is also something like an optimization kind of thing. This is not 1, let's say 10. Then if my upwards velocity is more than 10, it would automatically try to disable iStep without having to set up anything in the invalid animator, force invalid animator state, and all this also not set up this perfectly or whatever. You want velocity based invalidation of the foot IK, then you can set this to 20 or whatever you want it to have. But with -1 it's disabled. This is my preferred setting, because if you move upstairs, iStep is going to calculate an upwards velocity because the character moves up, and it's not using the character controller's velocity, because it's not like everyone is using this character controller. Other people use different custom character controllers, and because of that, it's not possible to know which current velocity is really applied and what movement adaptations or corrections are just for collision detection character controller. And if you would want to use this upwards velocity automatically with your specific character controller and all this grounded check with your character controller's grounded check, you can do that. You just have to extend the foot IK script and override the grounded check method code, and then you can just say, if your character controller, your custom one, says he's grounded, then you may, if you want to return in the function false, then iStep is going to be reverted, and so on. So I think you get what I tried to say here. I hope so. The next is the slope-based spine bending. This is all for the bending of the character. I'm not going to go into detail on this settings because this is all optimization and finding some cool values for you. What you have to know in here is that you have different methods of ground checks, or not only ground checks, but how the leaning detects how much it should lean. The algorithm is detected and change it here. Shoulder contact spine bending optimization. You can make your shoulders contact this bending and stuff like that. Ignore velocity dependency. I have a typo here, but this is so that this slope-based bending is always applied without the need of velocity. You can use it for debugging your values, but I don't recommend having this on all the time. It just by character makes, I think, no sense. The next one is very important. Relative spine rotation axis affected by its slope leaning. So every character may need a different axis setup in here, depending on how the axes in your character are. You have to select the right axis for the bending to be applied on the right axis. So I'm going to show you here. For debug, like I said before, we just ignore the velocity dependency. You see it's automatically applied like we would be running, and that's why this is used for. And if we would change this to the x-axis, it would be just the wrong axis, you see. And that's c-axis in this case, the right axis where he should lean to. And this is what you have to set up in here. All right, so let's move to the next. Let's disable this. Next is full body exaggeration leaning. This is the fake leaning. You can make some fake leaning in here. I'm not going to go into detail on that. Try out if you like these effects to manipulate some animations. The next footstep events, here you can trigger, or you can set up how the triggering of the events work with reset distance and with the step length. You just have to play around with these values to find the optimal values to get triggers right. Also on the trigger side, you can execute this play animation with a result, which is an ICAR result if you want to use a result, and without it. Both are possible. Just select what you want. You can set up here multiple events, however you prefer. And so this works. And the last one is the debugging. This is just for helping you optimize your values. If you want to use it, you can. All right, so that's it for this video. I hope it will help you to configure your characters. And thank you, and have fun with iStep. All the best for you with your games, and see you next time. Bye.